Exothermic versus endothermic reactions. Exothermic reaction. Endothermic reaction. Go H, enthalpy change. Negative, dot H, 0. Positive delta H quinone 0, released to surroundings, absorbed from surroundings. Energy diagram, reactants have more energy than products. Products have more energy than reactants. Stability, more stable products, less stable products. Had examples. Exothermic reactions. Delta H10, combustion, CH4 plus 2O2, CO2 plus 2H2O plus heat. Neutralization, HCl plus NaOH, NaCl plus H2O, bond formation, condensation liquid, freezing, liquid solid, some decomposition and dissociation reactions. O2, 2O, CS2C plus S2, 2NO, N2 plus O2, N2FeO, 2NO2, NCl3, N2 plus Cl2. Endothermic reactions, delta H0, photosynthesis, 6CO2 plus 6,2O, text, right arrow, 6H12O6 plus 6O2. Ionization of atoms, phase changes, solids, heat, liquid melting, liquid plus heat, gas, vaporization, decomposition, PCl through PCl3 plus Cl2, NH3, N2 plus H2 in some cases. Memory tricks, exo is equals exit, heat exits system release, endo equals enter, heat enters system absorbed, bond formation equals exothermic, bond breaking equals endothermic. Kirchhoff's law for heat capacities, used to calculate the change in heat capacity when temperature changes in a chemical reaction. R1 for constant volume, CV, boxed CV equal frac U2 minus U1, T2 U1. Internal energy at temperature, T1 minus U2 equals internal energy at temperature, T2. No volume change, work done equals 0. Heat equals change in internal energy. French 2. For constant pressure, CP, boxed CP equals frac H2 minus H1 minus T1, where H1 equals enthalpy at temperature T1, H2 equals enthalpy at temperature T2. At constant pressure, heat equals change in enthalpy. Quick tips. Kirchhoff's law is often used to calculate delta H or delta U at different temperatures. If Cp or Cv is constant, delta H equals Cp, T2 minus T1 equals Cv. Thermochemistry, enthalpy change, and reaction manipulation. 1. Multiplying the reaction. If text A, right arrow, text B, quad delta H equals X, then multiply by 2, delta H 2X, multiply by 3, delta H equals 3X, multiply by N's, divide by 2, delta H equal frac X 2, for clarity. Dasher 2, reversing the reaction, text B, right arrow quad. Delta H equals minus X. Sign of enthalpy changes. 3. Adding or subtracting reactions. If Knight's reaction 1, delta H1, reaction 2, delta H2, then add reactions, delta H equals H1 plus H2. Subtract reactions, delta H equals H1 minus H2. 4. Important hint for elimination. If a molecule atom is absent in the final equation, make sure it appears on opposite sides in the given reactions. That way, it will cancel out when you add the reactions. Emoji summary for quick revision. Multiply reaction, multiply enthalpy. Reverse reaction, reverse sign of enthalpy. Add equations, add enthalpies. Subtract equations, subtract enthalpies. Cancel intermediate, appear on opposite sides. Enthalpy of formation, del HF Grouch. Key concept. Absolute enthalpy is not defined. We only calculate del H, change in enthalpy. Delta H degree is the heat change when 1 mole of a compound is formed from its elements in their most stable standard states at 1 atom pressure and 298 K, 25 degrees Celsius. Standard state of elements, arbitrary 0. Some elements are assigned del HF degree equals 0 as a reference. Element, standard state, carbon, graphite, not diamond, phosphorus, P4, white phosphorus, sulfur, S-rhombic sulfur, bromine, Br2 liquid, iodine, I2 solid. Note, these are chosen because they are thermodynamically most stable and naturally occurring. And ensure formula for enthalpy of reaction. If reaction, AA plus BB, right arrow, CC plus DD, then delta H equal left C, C dot delta H F circ C plus D to CU, D, right, left, A plus B dot H B dot delta HF sur B. Emoji revision. Delta HF degree equals heat for forming 1 mole. Use elements in their most stable form. Br2 equals liquid, I2 equals solid. Delta H reaction products, reactants. Standard elements equals delta HF degree equals 0 with formulas and key. 1. Enthalpy of combustion, delta HC. Definition. The heat change that occurs under constant pressure when 1 mole of a substance undergoes complete combustion in oxygen. Always exothermic, delta HC is negative. Case 1. When delta HF, enthalpy of formation, is given, use this formula, delta HEC sum delta H reactants. Some formation is given, use this formula, delta HEC sum delta HF square X products minus delta H reactants. Some case 2, when delta HC combustion enthalpies of all species are given, use this formula, delta HF equals delta HC reactants, products. Special relations. Delta HF of H2OL equals delta HC of H2G, delta HF of CO2G equals delta HC of C, graphite. Final tip. If delta HF is given, use products reactants. If delta HC is given, use reactants product. Final tip. If delta HF is given, use products reactants. If delta HC is given, use reactants products. 2. Enthalpy of neutralization, delta Hn. Definition. Heat evolved when one equivalent of an acid reacts completely with one equivalent of a base in dilute aqueous solution. Standard value for strong acid, strong base, delta H neut equals minus 57.2 kJ per equiv, quad text or quad minus 13.7 text cases. Delta type of reaction, H neut value, delta energy neut then strong acid plus strong base, 57.2 kJ per equiv, weak acid, strong base, mayonnaise 57 kJ some energy, 0.2 kU, some energy used to ionize acid, and Gershfruner goods, strong point base, 37.2 kJ under 2 kJ under 52 kJ energy to ionize base, weak acid, even lesser value. Exception, HF has very high hydration energy, so when it reacts, more heat is released. Enthalpy of neutralization is more negative than usual. Order of neutralization decreasing delta H, D-text, HX, strong acid plus strong base text, weak acid, strong base, weak acid, weak base. Emoji revision, combustion equals exothermic, formation from elements. Use correct formula, delta HF equals reactant delta HC minus product delta HC neutralization minus 57.2 kilojoules for strong acid base. HF equals special case, more exothermic due to hydration. Of enthalpy, delta H. 1. Heat of Haltiad. Heat of hydrogenation. Hydrogenation. Definition, heat evolved during complete hydrogenation of 1 mole of an unsaturated compound to a saturated compound. Nature, always exothermic, delta H 0. Example, text C2H4 plus H2, right arrow, text C2 H6. 2. Heat of atomization, delhatomization. Definition, heat required to dissociate 1 mole of a substance into its gaseous atoms. Nature, always endothermic, right 0. Example, HU, right arrow, 28G. 3. Heat of transformation, delta H transformation, includes fusion, delta H fusion, solid liquid at melting point, endothermic vaporization, DHH vaporization, liquid gas at boiling point, endothermic sublimation, delta sublimation, solid gas, directly endothermic. 4. Heat of hydration, delta hydration. Definition. Heat evolved when 1 mole of anhydrous salt combines with water to form a hydrated salt. Nature, exothermic. Example text, QSO4 plus 5H2O, right arrow text QSO4, C.5H2O. Nash. 5. Heat of solution, definition, heat of solution, definition, heat change when 1 mole of a substance is dissolved in a large volume of water so that no further heat change occurs. Nature, can be exothermic or endothermic, depends on the solute. 6. Bond dissociation energy, bond energy. Definition, energy required to break 1 mole of bonds of a gaseous molecule into gaseous atoms. Always endothermic. Example, right arrow 2Cl of GF. Choosing the right formula for delta H. Use this right formula for delta H calculate H calculation, 2Cl of GF. Choosing the right formula for delta H calculation. Use this formula. Use this for reactants. Minus C enthalpy of formation. Delta H equals C delta HF products minus C delta HF reactants. Enthalpy of combustion BHC. Delta H equals C delta HC reactants, C delta HC products. Bond energy. Delta H equals to C bond energies of reactants minus bond energies of products. Quick conclusion. Delta given, products, reactants, delta HC given, reactants, products, bond energy given, reactants, products. Value CV, def value CV. Definition, calorific value is the amount of heat evolved when 1 gram or 1 mole of a substance is completely burnt or oxidized. Key formula, text total heat released, text calorific value times max unit awareness, very important, very important. If CV is given in, multiply with final unit for unit of CV first. kJ kilojoule per gram, mass in grams. kJ mole, kilojoule per mole, number of moles, kJ. Tips for solving questions. Always check the unit of CV first. Match the unit of CV with either grams or moles. Use unitary method. If 1G gives 30 kJoules, then 5G gives 30, 50 kJoules, then 5G gives 30, 50 times 5 on 50.